happy National Puzzle Day. And so, in honor of National Puzzle Day, we're going to take the law of signs and we're going to make it puzzling today. Because we're going to add in something called the ambiguous case of the law of signs. Okay? So today is law of signs with the ambiguous case. We haven't updated our calendar in the back yet. And then tomorrow you're going to have a formative. Okay? So just so you know, it's 2 questions. It's 2 law of signs questions. That's all it is. 12 answers. Good to go. Okay, so you're solving 2 triangles tomorrow on the formative. That's it. Okay? You should have picked up a homework packet when you came in today. Now, those problems are all kind of mixed in, so you can do some of them. You can't do some of them yet because some, like for instance, you can do number 1, but you can't do number 2. Okay, because you haven't learned law of cosines yet. It's not like the numbers 1 through 4 are law of sines, 5 through 8 are law of cosines. They're all kind of mixed in together, and then the word problem's yet. So you got to kind of jump around a little bit in there if you're doing that. Okay? All right. So let's take a step back to yesterday. Okay? We learned the law of sines. Okay? The ratio of an angle and its opposite side is the same for each of the 3 vertices in any triangle. Okay? SOHCAHTOA only works on right triangles. Law of sines works on any triangle. Okay? Okay? So that's why law of sines is there, because we don't always have right triangles. Okay? Okay? So that's what we had yesterday. I do believe that there isn't anything else on that one. Perfect and Schlag. Okay? So, back when you were in geometry, you learned 5 different ways to prove that triangles were congruent. Right? Okay? The first way, and all of these 5 only result in one possible outcome, one possible triangle. Okay? So, today and going forward, these aren't necessarily ways to prove triangles. These are ways to show that there is only one triangle. Okay? So on all of these 5 methods, there will only be one triangle produced, and then you can use law of sines or next week law of cosines on them. Okay? So the first combination that results in only one triangle is side, side, side. Okay? When you were proving it, you needed to have the 3 sides of one triangle be equal to the 3 sides of another triangle, or corresponding sides needed to be equal. Now, here in math, or in pre-calc, when we're solving triangles, if you have side, 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 you get one triangle and you use the law of cosines to find it, to find the angles. Okay? All right, so that one we can't quite do just yet. Side, angle, side, you would have angles. Actually, here, let me put this. Let me go here. Let me go here. Let me go here. So this would be, you are given A, B, and C. Okay? Side, angle, side will produce one triangle. Okay? And it would be A, B, and angle C. You would have that scenario. Also utilizing law of cosines. Okay? So if we're solving that one would have law of cosines in it. Next one is angle, side, angle. So now we actually did some of these yesterday where we had angle A, side C, and angle B. Okay? And we did those yesterday. We can solve that triangle because we can find that third angle because the 3 angles of a triangle add up to be 180 degrees. That gives us the law of sines, one complete fraction. We find the other 2. Okay? Next one is angle side side, or excuse me, angle side, excuse me. So we would have angle A, angle B, and side A. And that also would be law of sines, because we have the one complete fraction, and we can go on with that one. Okay. The fifth method is hypotenuse leg, and that only works for right triangles. And so for that one, we would just use SOHCAHTOA. If we needed to solve that triangle. Okay? So the first two, side, 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 and side angle, side, that's law of cosines. We'll get to that next week. Okay? If I'm not mistaken, we start law of cosines, I believe, on Wednesday. Okay? Angle, side, angle, 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 side, that's law of sines. Okay? And that we can do right now. Thanks, Wifey. Don't be laughing at Wifey.
I apologize.
And then hypotenuse leg, that's right triangles. That is SOHCAHTOA. Sorry, lost my train of thought there. Okay? Yeah? Love it. So, that leaves the angle side side case. Yes, I'm going to say a naughty word here, okay? But it's in the Bible, so it's okay. Okay? That's nice. Because it also means donkey. Okay? Okay? You cannot prove that triangles are congruent, and you probably learned this back in geometry. You cannot prove triangles are congruent with your ass. Okay? Your angle side side. Okay? It's written right there, Carlos.
I know.
It's right there.
I
Okay?
can read.
Okay, the elephant's already in the room. It's already on the board. Okay, right? The angle side side case is also the ambiguous case. Okay, so what I would like you to do is, in this triangle right here, I would like you to find me, using the law of sines, I would like you to find me angle B. Okay, I'll give you just angle B, not the whole triangle. Just finding angle B. Okay? Go for it. Anybody? What did we get for angle B? Say it loud. 64.783. Is everybody get that? Yes?
I got 22.296.
Row.
I got 64.
I don't know what you did wrong. Sine 31, sine B 12.
Then you got I think I did it wrong.
I think you typed it in wrong in your calculator. Yeah. Okay. Here's the problem. I got $115.217 degrees.
I'll just take that and then go
Zoinks.
here, and then go
Ruh-roh.
side of negative one.
Scooby's my favorite.
Yeah. and
There's
then
nothing
go-
better than good
I
Scooby
see
snack.
now. I see.
Okay. All right. Who's right? Well, I don't know. Let's check it. Okay. Let's go back and let's check it. Okay. All right. So if we set this up again, so you guys, we all set this up as the sine of 20.5 degrees all over 12 equaling the sine of 64.783 degrees all over 31, which is also supposed to be equal to the sine of 115.217 degrees all over 31. Okay? So You guys all got 64.783 and it worked out, right? Okay. So find me, just figure out for me on your calculators what this green fraction is. I'll figure out what the other one is. No, I need to do this. Give me this. There we go. Now it's a calculator I can use. Sine of 115.217 divided by 31. Did you guys both, did everybody get, or I got 0.0291839?
Yeah.
Yes? Yeah? So this one is that one too. Are we going to assume that that middle one's the same? Every once in a while it does that. The screen just went black. Sine 64.783 divided by 31. Get the same thing. Yeah? Okay. So they're all equivalent. So again, I ask, who is right? We both are. Yeah, exactly. We both are. And this is the ambiguous case of the law of sines. Okay? So the definition of ambiguous is that it is open to more than one interpretation. Okay? Now, the ambiguous case only happens in when you have an angle side case. Okay? So that's the only time that you are going to have an ambiguous case that you have to look for. Okay? So only if you're given an angle and then two consecutive sides. Okay? Side angle side, when you're given two sides and the included angle, that's not an ambiguous case. Okay? Angle side angle, where you're given two angles and a side, not an ambiguous case. Okay? Only when it's your angle side side. Okay? So, there's different scenarios that you are going to have to look for then, and you're going to have to kind of get to know these so that you understand. Okay? So the first case is the given angle is obtuse. Okay? So what this is going to look like is, in an obtuse case, oops, this one. So I'm given this angle here. It is obtuse. And then I'm given two consecutive sides. I don't care if it's this side and this side, or if it's that side, you know what I mean? Either, it doesn't matter which way you go around, but you're given two consecutive sides. Okay? What's up? Yeah. Because if this one was down here, then it's side angle side, and that's not ambiguous. Okay? So it's got to be two consecutive sides. So so we're going to call this one, we're going to borrow some terminology from SOHCAHTOA. Okay? So I'm going to call this one the adjacent side, because it's the one that's touching it. Okay? And I'm going to call this one the opposite side, because it's the one that's across the triangle from it. Okay? So I'm going to borrow that terminology from SOHCAHTOA. If the opposite side is bigger than the adjacent side. So if the opposite side is bigger than the adjacent side, you get one triangle Oops, let me put the formed underneath. You get one triangle, and you use law of sines like you were using law of sines yesterday and back when you were in geometry. Okay? So only one triangle is formed there. If those roles are reversed, so if the opposite side is now shorter than the adjacent side, let's think about that one for a second. It's what? It can't be obtuse then, right? Because what we learned yesterday, what we learned in geometry is the longest side is opposite the biggest angle. And we can only have one obtuse angle, so that opposite side has to be the longest side of that triangle. So if the opposite side is less than the adjacent side, there is no triangle formed. Okay. Questions on that? Love it. Okay. Now, my given angle is acute, or acute. Oops. Okay. So now we have our angle. I'll go this way this time. Side 1 and side 2. Side 1 again is going to be my adjacent side. Side 2 again is going to be my opposite side. Once again, doesn't matter which way you go around the triangle. Okay? So if the opposite side is bigger than the adjacent side, then you lucked out and you get one triangle formed. Use law of sines, figure out the missing 3 parts, move on with your day. The real ambiguous case comes in when the adjacent side is longer than the opposite side. So that is the one key thing that you're looking for. Okay? Is if the adjacent side is bigger than the opposite side. The first thing that you are going to have to do is you are going to have to find the height. Let me label. Sorry, I forgot to label. So here's my angle. Here's my side 1. Here is my side 2. Side 1 is my adjacent side. Side 2 is my opposite side. Height right there. The height, remember, is perpendicular. So you would use SOHCAHTOA. You would really use the sine of your given angle is equal to the height divided by side 1. So your height here is going to be the adjacent side times the sine of your given angle. You need to do that first because depending upon that height and its relationship to the opposite side, that is going to determine what kind of triangle you have, if any. Okay? So our first option is that this opposite side in red is equal to the height. And if that is the case, then we have one right triangle formed. Okay? And that's possible. Sorry, let me scroll down just a little bit. Oops, I guess I didn't realize I had those underneath. Okay. So if we have that's the case, then we get one right triangle, and we can then use SOHCAHTOA. Okay? If the height is bigger than the opposite side, then we get a weird scenario where this side length right here isn't long enough to reach down and touch that bottom side. Okay? It just kind of swings here like a pendulum. Okay? It's not long enough to get down there, so we can't ever close that figure, so we don't get any triangle. We get a no triangle case. And if the opposite side is longer than the height, then we get the true ambiguous case, because as this side here is swinging like a pendulum again, okay? So it's just kind of swinging like that. As it swings, it meets this side over here, and it swings back and makes another triangle in there like that. Okay? So it makes two distinct triangles. So you have to find, in this case then, you would have to find 12 things. Really, you'd only have to find 9 things, because the 3 things are going to be the same on each one. Okay? And so in the ambiguous case, we only ask you to find the 3 things that are missing twice. Okay? Are you guys, you want me to do a problem and then go through the steps on what we would have to do? Or do you want me to give you the steps right now so you have them right here with it? It's like of what you would do. Steps right now? Okay, all right. So the first thing that you're going to do then, when you're in this case, so if you were coming to this problem, the first thing that you would do is you would find H to compare it. Okay? That's because it's the ambiguous case, that's the first thing that you got to do anyways. Okay? Then you figure out if there's 2 triangles or not. Let's say that there are 2 triangles. Then the next thing that you're going to do is you are going to find angle B sub 1 with using your law of sines. Okay? So you're going to find the first angle that you get using the law of sines. That's going to be actually, you're going to find, so this would be angle A, and then here, this one would be angle B sub 1. That's the one that you're going to find first. Okay? Then you're going to find angle C sub 1 and side C sub 1. Okay? You're going to finish off the law of sines on that top triangle. Okay? Then what's going to happen is now you're going to come down here and you're going to say, okay, now I got to find my second triangle. So angle B sub 2 is going to be 180 degrees minus angle B sub 1. And this in here, let me put this in here. This is angle A still. This is angle B sub 2. It is the supplement of angle B sub 1. Then after that, then you would find angle C sub 2 and side C sub 2. Okay. Okay. So in a nutshell, if you've got an angle side-side case and the opposite side is greater than the adjacent side, you get one triangle and you solve it using law of sines. If the opposite is greater than the adjacent, actually here, hold on one second. I'm going to move that over just because I can. Okay. If the opposite is less than the adjacent side, then this is where you get 0, 1, or 2 triangles. If it's obtuse, if the angle given is obtuse, you get no triangles. Okay? If the given angle is acute, first thing you're going to do is you're going to check the height. Okay? And if the height is equal to the opposite side, you get one right triangle. If the height is bigger than the opposite side, you get no triangles. And if the height is less than the opposite side, you get 2 triangles. Okay? Ready to do some? Let's get into it. All right. So here we go. Cannot stress this enough. That drawing yourself the simplest of simple pictures helps you out dramatically in these problems. Okay? All right? So we have here angle A is 42 degrees. We have side B is 12. We have side A is 22. So that to me says we have an angle, a side, and a side case. Yes? Now if you put your 12 on the bottom, that's fine. Okay? Again, doesn't matter where it goes, it's still an angle side case. Okay? So then this would be angle B, this would be angle C, this would be side C. We might have 2 of them, right? Okay? So our first check is yes, this is an angle side case, so we have to continue to check for ambiguity. Okay? in this particular case, what is my relationship between my opposite side and my adjacent side?
Opposite is bigger than adjacent.
Opposite is bigger than adjacent. Okay? So according to our notes, opposite is bigger than adjacent. How many triangles do we get? One triangle, right? Okay? So that means one triangle, because that is the always case. It's always going to be one triangle. Let's solve for it. Okay? So then we can say now that the sine of 42 degrees all over 22 is equal to the sine of angle B all over 12. Do you concur with that? Yep. Okay. So then angle, actually, let me, because we're day 2, I won't jump right into just going right into doing it. So then we would say 22 sines of angle B is equal to 12 sines of 42 degrees. Sine of angle B is 12 sines of 42 degrees divided by 22. Angle B then is going to be the inverse sine of that. Calculate for me, if you will.
21.406.
21.406?
Yeah.
I would concur. Okay. So far we have angle A is 42 degrees, side A is 22, angle B is now 21.406 degrees, side B is 12, angle C is what? $116.594. And side C, now we can say that the sine of 42 degrees all over 22 is equal to the sine of 116.594 degrees, but we're going to leave that on our calculator because there's probably more decimals after it over side C. Crisscross applesauce. C sines of 42 degrees equals 22. Sines of 116.594 degrees. C is going to be this. So C is, I got 29.4001. Agree? Yeah? Love it. Okay? Try it on your own. Go for it. So we've got angle C here now is 85 degrees. We've got side A here is 25. We got side C is 15. that would then mean that this would be angle A and this would be angle B. And we decided that we've got the angle side case, yes? Okay. And we determined that the opposite, oops, hold on a minute. The opposite is less than the adjacent, right? So we need to check our height. So there is my height. So that is going to be the sine of 85 degrees is equal to the height over, oops, tap the brakes. Let me just move this. Let me slide this over here. Sorry. And in this case, I think no. No, sorry. Erased the wrong one. In this case, I want to make my triangle here. Because then we have the, so we have the SOHCAHTOA. Couldn't think of SOHCAHTOA there for a minute. Then we have SOHCAHTOA set up for us. So the sine of 85 is h over 25, which means h is going to be 25 times the sine of 85 degrees, which is going to then be approximately 24.905. Agree with me on that? Okay? So we have to compare the height to the opposite side. So my height is 24.905. My opposite side is 15. So this is a height is bigger than opposite side case, which means no triangle. So then you're done. Because the triangle wasn't formed. Okay? Love it. Let's do this one. Okay? So first off, we need to make ourselves a triangle. Angle A is 35 degrees. Side A is 15, and side B is 17.5, which would make this be angle B, this angle C, and that side C. Confirmed angle side case. What's the relationship between the opposite and the adjacent? Adjacent's bigger. Yep. So that means that we have to find the height. Height then is going to be the sine of 35 degrees times 17.5. .5 sines of 35 gets me, I get approximately 10.0376. Yes? Okay. How is that in comparison to the opposite side? Smaller. So how many triangles are formed? Okay? First triangle is normal triangle. So we can do the sine of 35 degrees all over 15 is equal to the sine of angle B all over 17.5. Agree with me on that? Let's work it. Sorry, this should be B sub 1. Stop it. Trig inverse sine of 17.5 sine of 35 divided by 15 gets me, I get 42.0032 degrees. And I am going to store that on my calculator as angle B, because we're going to have to use that later on. Okay. Then we can say that angle C sub 1 is going to be 180 degrees minus 35 degrees minus 42.0032 degrees. So I get angle C sub 1 as 102.997 degrees. And I'm going to store that as my angle C. Then I used purple, I used green, I used blue, we'll just go black. Then we can say that the sine of 35 degrees all over, is it 15? I forget. Yep, all over 15 is equal to the sine of 102.997 degrees all over side C sub 1. So then side C sub 1 is going to be 15 sines of that divided by the sine of 35. I know, like I said, lots of writing. 15 sines of angle C divided by sines of 35. I get 25.4818. With me? Okay. Now, back over here, now we got to go to our second triangle. So we found angle B sub 1 first. So angle B sub 2 is going to be 180 degrees minus angle B sub 1. So 180 minus angle B gets me 137.997 degrees. And I'm going to store that now as my new angle B. Then angle C sub 2 is going to be 180 degrees minus 35 degrees minus 137.997 degrees. That's going to give me 7.00323 degrees. I'm going to store that as my new angle C. Now, here's the nice part. You've already done the math for side C sub 1. If you wrote it out, it's all right here. The only thing that's going to change is this angle. Angle C is going to change. So side C sub 1, or excuse me, side C sub 2 is going to be 15 sines of 7.00323 degrees, all divided by the sine of 35 degrees. The only thing that changes in this is this angle right there. So that would be this angle right there that changes. That just changes to your new angle C. And if you have one of those wonderful calculators that you can just scroll back up on, you can just scroll back up on and just change that angle. And you get side C sub 2 is 3.18855. Okay. So, putting this all together now, we had angle A was 35 degrees. Side A was 15. Side B was 17.5. Angle B sub 1, and you've got to label which one is which. Okay? Angle B sub 1 was 42.003 degrees. Angle B sub 2 was 137.997 degrees. Angle C sub 1 was 102.997 degrees. Angle C sub 2 was 7.003 degrees. Side C sub 1 was 25.482. Side C sub 2 was 3.189. And there are the 9 answers that you need to come up with in a double triangle case. Woo! Good God, man. I get it. I get it. Thanks for playing along and listening to 40